Hey, I'm it's supposed to say that's my line.
Well, then say it.
Go home, folks.
When you observe an apple falling from a tree, the apple falls because the apple has weight. It weighs more than the air that surrounds it, therefore it falls. Gravity is the theory that when something has mass, things are drawn to it. So you could have a ball, and water is drawn to that ball, and when the ball spins, the water should stay on, but the water flies off. If you've ever seen a dog get wet, it shakes and the water flies off. I've never seen any evidence of gravity in my life.
Earthling! Earthling! Hurry! Hurry! They very near! No time! No time!
Which is heavier, a pound of feathers or a pound of bricks? This is a classic trick question, and I'm sure you know the answer to it. They each weigh a pound, and so they are the same weight. But there is something different about a pound of feathers and a pound of bricks. A pound of feathers will take up much more space than a pound of bricks. But why is that? Well, a pound of feathers would be much less dense than a pound of bricks would be. Density relates two units that are commonly used to describe matter: mass and volume. Remember that mass is a measure of the amount of matter, or how much stuff there is, and volume is a measure of how much space that matter takes up. When we put these units together, we come up with density. And so density is the amount of matter per unit of volume. And we could calculate density using the following equation. Density is equal to the mass of an object divided by its volume. Let's compare a substance with a high density to a substance with a low density. Air has a very low density. If we had 10 grams of air, we would have over 8 liters of air. Remember that grams is a measure of mass, and liters is a measure of volume. And so 10 grams of air would be enough air to fill over 10 2-liter pop bottles. Now let's consider a highly dense substance. What if we had 10 grams of lead? 10 grams of lead would occupy less than 1 cubic centimeter of space. Just a side note, when we're working with solids, we usually use centimeters cubed as a unit for volume instead of milliliters. Just so you know, 1 milliliter is saying the same thing as 1 centimeter cubed. And so we use centimeter cubes when we're talking about solids. And we use millimeters when we're talking about liquids and gases. Okay, so how much space does 10 grams of lead take up? Well, we could fit 10 grams of lead into a small nail. Here we have the exact same mass as the 10 grams of air, and yet it's taking up much less space. And so we could say that lead is much more dense than air. Let's try calculating density based on some measured values. Remember our equation for density. If you had a cube of copper that had a volume of 16.7 cubic centimeters and a mass of 150 grams, what is its density? Using the equation above, we can see that density will be equal to mass divided by volume. And so the mass is 150 grams divided by the volume of 16.7 cubic centimeters. We'll see that the density is equal to 8.98 grams per centimeter cubed. And that's our final answer. Let's try another one. This time I'll give you the density and the volume, and you'll find the mass of the object. Here's a bucket filled with seawater. The density of seawater is 1.027 grams per milliliter. And this bucket has a volume of 15 liters. What is the mass of the seawater? The first thing we should do is write down the equation that we're going to use.
Earthling! Lie. Lie.
The next thing I want to do is just double check that all my units are in SI units, or at least agree with each other. If I take a look at my units for volume, I can see that liters are listed here and milliliters are listed here, and I need to have a common unit. Since my density is usually measured in milliliters, I'm going to convert the 15 liters into milliliters first. To do that, I'll multiply by a conversion factor that compares milliliters to liters. There are 1,000 milliliters for every liter, and I can see my liters will cancel out and I'll be left with milliliters. And so 15 liters is the same as 1.5 times 10 to the 4 milliliters, or in other words 15,000 milliliters. Now that we have like units, let's rearrange our equation so that mass is isolated on one side of the equation. To do that, I'll multiply both sides by V to move V to the other side of the equation. Now volume will be cancelled on the right side of the equation and be left over here on the left side of the equation. Let's rewrite this equation now. And so mass is equal to density times volume. As I can see, I flipped the equation just to make it look a little bit nicer down here. Let's plug in the numbers and solve. We can see that milliliters will cancel and we'll be left with grams, which is what we want for mass. Here's our final answer, 1.54 times 10 to the 4 grams. We can also see that we have the correct units, and we also have the correct number of significant figures. In our answer here, we have 3 significant figures, and our least significant measured value was over here with 1.50 times 10 to the 4, which is all.